Next, we are looking at capacitive reactance. So what is reactance? We have already discussed. Read through. So it's a special type of resistance that is offered to the flow of AC current. Now, here in this case, we are looking at capacitive reactance. That is when we introduce a capacitor in your AC circuit, right? When we switch it on, what and all problems it will create. Not exactly problems, but resistance, right? That's your capacitive reactance. The actual definition is capacitive reactance is the effective resistance or the opposition that capacitor presents to the flow of an alternating current. So how do we denote it? XC. So what is the math? So we know that we have your, how do I write it across? I is equal to I naught sine of omega t plus pi by 2, right? So what is I naught over here? Try to recall. Right? So where I naught is equal to, yes, we have omega c E naught. Now, if we compare this with, on comparing, with R P is equal to IR, so I is equal to V by R actually. So what do we end up with? Right, so comparing with, let me write it off. So what do you end up with? We have V to be this, and R will be equal to 1 by omega C. And that is nothing but your XC. As simple as that. Okay, yes. Of course, this can be further written as 1 by 2 pi FC. That's it. As simple as that. That is your capacitive reactance. Now, this will make sense now. What if we have DC source? Then your frequency will be equal to 0. So what will happen to XC? 1 by 0, which is infinity. This is what happens, right? We saw that in the very first video when we started talking about capacitor. We saw that after some time, it offers a lot of resistance and leading to the circuit just stopping, right? We have seen this. Your RC circuit, after a certain point of time, after we switch it off, so switch it on, what happens? It stops. Okay, does it make sense? Now, how does it vary with frequency? So again, let's go back to that expression. So what do we have? We have it in the denominator. So 2 pi fc. So it is inversely proportional. This implies xc is inversely proportional to 1 by f. So basically, your graph will look something like this. So say this is your xc and that's your frequency. As a when you, since it's inversely proportional, your graph will look like this. So this is how it look. It will decrease and as and when you increase the frequency. So basically the capacitor effect will reduce as and when you increase the frequency. Okay guys, again, it's simple maths and also common sense. If you apply both, then it will start making sense. Now pause and have a look.